G'day everyone, my name's Matt and welcome back to another episode in a series of videos talking all about fire and fire behaviour. In today's episode we're going to be talking about flame types, namely premixed flames and diffusion flames. And we're going to be talking about how they're different and when we would expect to see each one of them. So we're going to go ahead and we're going to start with premixed flames. Now to demonstrate a premixed flame, I'm going to be using this blowtorch, which has a blockable aperture hole at the end of the nozzle. And this hole will actually allow me to control how the air is getting to our fuel mixture, and then we can control what type of flame type we have. Now the fuel we're going to be using is a propane gas, which is a hydrocarbon, and the oxygen for our reaction is coming from the air around the blowtorch. And it's actually how that air is getting to our fuel mixture is what's going to dictate what type of flame we've got. So we're looking at this now, we've got our nice blue flame, which is our premixed flame. And this is occurring because our fuel, as you can see, is coming up from our cylinder and it is being joined by the air in the nozzle itself before combustion occurs. And this is the air being drawn in through those aperture holes. It's mixing with the fuel before combustion occurs, and it's mixing at a precise ratio which is being designed specifically for propane to burn cleanly. Now this is what we're talking about by premixed flame. We have our fuel coming through, it's mixing with our air at a really precise ratio, and then we're getting complete combustion as a result. And that's why we're getting our nice blue flame, because it's actually a really efficient and really hot flame because it's burning with the greatest amount of intensity that it can do. Now the byproducts from this reaction are just going to be carbon dioxide and water, because the fuel is already being mixed at the precise ratio for the right amount of oxidizer. So everything that is in the fuel is being fully oxidized, which is just going to leave us with carbon dioxide and H2O, which is water. So we have a complete combustion reaction in this one, which is different to our diffuse flame, which we will be showing next. Now for a diffuse flame we can use the same blowtorch, however what we're going to need to do is block those aperture holes in the end of the nozzle. And you can see straight away that we've transferred from that blue flame to a much more yellow flame, and it's less of a jet and more of a flickering flame now. And this is because our fuels are no longer being pre-mixed at a specific ratio inside the nozzle. So we don't have that really good fuel to air mixture anymore. And what's happening is the air is actually being drawn, or the oxygen for the reaction is being drawn from past the end of the nozzle. So we get a much less efficient reaction from our propane gas. The result of which now is we're no longer getting that complete combustion that we were seeing from the premixed flame. Now we could actually expect to be seeing both carbon dioxide and water, like we saw before, but we'd also be seeing carbon and carbon monoxide as a part of our reaction, which is to say that we're no longer fully oxidizing our fuels, we're actually being less efficient. And as a result, our flame temperature is nowhere near as hot as it was before, which is one of the reasons why it's actually changing to that yellowish colour, because it's not as hot as it was before. And this is the main difference between our premixed flames and our diffuse flames, because when they're premixed, all these products and fuels are being fully oxidised, and therefore the reaction is complete. However, in a diffuse flame, what we're getting is this incomplete combustion, and therefore it's not as efficient, and we're getting a lot of waste products being emitted. Now a few examples of where we might find a diffusion flame are structure fires, car fires, vegetation fires, training fires, and fires you probably shouldn't try at home. Alright, so now we've seen our premixed flame and our diffusion flames, and we've seen that the two really are quite different. With our premixed flame, the oxygen and the fuel are being mixed together before the point of combustion, and they're mixed together in just the right ratio for every piece of fuel that's there, there's the right amount of oxygen. And therefore that burns really cleanly, and we see that nice blue flame. And there aren't a lot of unburnt products coming off this as well. This is actually a fairly clean kind of combustion, which means that we're generally just going to be getting carbon dioxide and water off our premixed flame combustions. That is to say that it does depending on the engineering standards. For instance, in our home cookers, our gas burners on our stove at home, they're generally of a higher engineering standard than, say, on our barbecues or these kinds of things. because in the case of a barbecue or an outdoor heater, they're still releasing carbon monoxide. And in an outdoor setting, that doesn't really matter. It simply floats away without doing any harm. But if we started using those sorts of things in our home, then obviously we could get a buildup of carbon monoxide, and that could be quite dangerous. So they're really not suitable for indoor use because they aren't quite as efficient as the other ones that we do see that are designed for indoor use. Diffusion flames are very different. They do produce a lot of unburnt products. We do get carbon dioxide and water, but we also get carbon monoxide, carbon, and whatever else happens to be in the product that's being burnt. That's being released, and it may be oxidized or it may not. And either way, it can be very, very harmful towards us. So it's good to know what's actually in there. And in the cases of structure fires and bushfires and all these kinds of things, it really does show that we need to be very careful when we're thinking about how our exposures to smoke and really try and minimise that, because it is all harmful to us. All right, that's it for this one. Thanks very much for watching, and catch you in the next one. Cheers, bye.